Welcome to TechNova Podcast.
All right, welcome back, everybody, for another deep dive. And today we are talking about something pretty exciting. Intuitive Machines, Athena lander, and its recent touchdown on the moon.
Very exciting stuff, yeah.
We've got this really cool article here from space.com, and it details the landing. And, well, you know, they make it pretty clear it was a nail-biter.
Oh, yeah.
So Athena landed right on schedule March 6, 2025 in the Mons Mouton region.
Okay.
But the team wasn't initially sure if it had landed upright.
Oh, wow.
And yeah, that's like super crucial for communicating with the lander and making sure the solar panels are getting enough sunlight.
Yeah, absolutely.
It kind of makes you think about their last lander, Odysseus, which had a little bit of rough landing last year.
It does, yeah. It definitely has that same feeling of anticipation. Odysseus, you'll remember, was the first private spacecraft to land on the moon, but it ended up on its side after a hard landing. I mean, they were able to get it working, but it certainly added a lot of stress for the team, so I can understand why everyone's holding their breath waiting for confirmation on Athena's orientation.
Absolutely. And what's even more interesting is that Athena's mission is focused on the lunar South Pole.
Right.
So it's not just about, sticking the landing. It's really about strategically exploring a region that could be key to a future lunar base.
Yeah, the lunar South Pole is generating a lot of interest right now, and for good reason.
Yeah.
Scientists believe that permanently shadowed craters in this region could contain substantial amounts of water ice.
Okay, so we're not just talking about a little bit of frost here and there, right?
No.
This is potentially enough to support a long-term human presence on the moon.
Exactly, and that's what makes this mission so important.
Wow.
Athena is part of NASA's CLPS program,
Okay.
the Commercial Lunar Payload Services Program, which is all about utilizing private companies like Intuitive Machines to get important science payloads to the moon. This approach is more cost-effective and helps foster the growth of the commercial space industry.
That public-private partnership aspect is really fascinating.
Yeah.
But back to the South Pole. What makes it so unique compared to other areas on the moon?
Well, it all comes down to the unique conditions at the poles because of the moon's tilt. Some of these craters never receive direct sunlight. They've been in shadow for billions of years, which allows them to act like giant cold traps. Any water molecules that find their way in there essentially get frozen in time.
Wow. That's incredible to think about these pristine pockets of lunar history just waiting to be explored.
Precisely. And the potential of that water ice extends far beyond just drinking water.
Oh, okay.
Think about the possibility of producing propellant on the moon.
Okay.
That would be a game changer for future missions, allowing us to launch missions further into space from the moon itself, rather than having to haul all that fuel from Earth.
That would be incredible. So Athena's mission could have implications for deep space missions as well.
Absolutely. But first, we need to confirm the presence of water ice and learn as much as possible about its distribution and composition. And that's where Athena's primary payload, Prime 1, comes into play.
Prime 1, that name sounds familiar, but refresh my memory on what that's all about.
Prime 1, which stands for the Polar Resources Ice Mining Experiment, is a pretty remarkable piece of technology.
Okay.
It has a drill that can penetrate up to 3 feet into the lunar surface, and it's equipped with a mass spectrometer to analyze the composition of the soil samples it collects.
So they're not just looking for water ice, they're actually analyzing the makeup of the lunar soil in that region.
Right. The mass spectrometer acts like a chemical fingerprint analyzer, helping us identify the presence of water ice, but also other volatile compounds like methane and ammonia.
Okay, so why are those other compounds important?
These volatiles can give us clues about the history of the moon, potentially even hinting at whether it's ever harbored any form of life.
Wow.
They can also tell us a lot about how the moon formed and evolved over billions of years.
So it's like a time capsule of lunar history locked away in those shadowed craters.
Exactly. And each layer of soil that Prime 1 digs into could reveal a different chapter in that story.
Oh, wow.
We're essentially peeling back layers of time with this mission.
That's such a cool way to put it.
Yeah.
And it's not just Prime 1 along for the ride. The article mentions a few other robots that are part of this mission. There's something called a hopper named Grace.
Yes, Grace is a small spacecraft that's designed to hop around the landing site using its thrusters. Think of it like a mini explorer that can potentially reach areas inaccessible to rovers.
Like those shadowed craters we were just talking about.
Exactly. A rover might have a hard time navigating the terrain around those craters, but Grace could hop right over those obstacles and potentially even peer inside.
Wow, a hopping spacecraft. That sounds straight out of a science fiction movie.
It does, doesn't it? But this is the reality of modern lunar exploration.
Wow.
We're using innovative technologies to push the boundaries of what's possible.
And what about the other robots mentioned, MAPP and AstroAnt? What are their roles in this mission?
Well, MAPP is a rover equipped with cameras to explore the area around the landing site, taking high-resolution images and thermal readings.
Okay.
It's carrying the AstroAnt prototype, a tiny swarm robot developed by MIT.
Okay.
Essentially, we are trying to test how swarms of small robots might be used for future missions.
So Athena has a whole entourage of robotic explorers. This mission is truly pushing the boundaries of lunar exploration. It's amazing to think that it's all happening right now, but before we get ahead of ourselves, let's go back to that initial cliffhanger. We still need to know if Athena is upright and ready to get to work.
You're right, that's the big question mark hanging over everything. The article mentions a press conference where the team will provide more information. Hopefully by then we'll have a clearer picture of Athena's condition and whether it's ready to start its mission.
Okay, so last time we were talking about Intuitive Machines' Athena lander and that heart-stopping moment when everyone was waiting to see if it landed upright.
Oh, yeah.
The suspense was killing me.
Yeah.
I had to go back to that space.com article and get the update. Did they say if Athena pulled it off?
The good news is yes. The mission team confirmed at the press conference that Athena is upright and sending back good data.
Q.
Quite a relief, I'd imagine, for everyone involved.
Oh, absolutely. A huge testament to the team's skill, and knowing that Athena is in good shape really amps up the excitement for everything it's going to accomplish. The article said they've already started using Prime 1, that drill and spectrometer combo we talked about.
Yeah.
I can't wait to see what they dig up, literally.
Yeah, it's a huge milestone. This is the first time we're robotically drilling at the lunar South Pole. Remember, every bit of data Prime 1 collects is going to help fill in the gaps in our understanding of this region.
We were talking earlier about the possibility of finding water ice, which would be incredible, but I'm curious, what other kinds of discoveries could Prime 1 make? What are the scientists really hoping to find?
Well, confirming the presence of water ice and figuring out how much is there is definitely a top priority. But Prime 1 is also going to be analyzing the composition of the soil itself.
Okay.
It's looking for what we call volatile compounds, things like methane or ammonia.
Why are those volatiles so important? It seems like water would be the main prize.
Volatiles are like fingerprints that can tell us about the moon's past. Think of it this way. They evaporate easily at normal temperatures, but they can get trapped in cold places like those permanently shadowed craters.
Okay.
Finding them can help us understand the history of the moon's surface and its interaction with things like comet impacts or volcanic activity. It's like piecing together a puzzle of how the moon came to be what it is today.
That's fascinating. So each layer of soil that Prime 1 digs into could represent a different era of lunar history.
Exactly. And those volatiles can even offer clues about whether the moon has ever harbored any kind of basic life forms.
Really?
It's a long shot, of course, but the possibility is incredibly intriguing.
Wow. I never thought about it that way. It seems like every aspect of this mission has the potential to rewrite what we know about the moon. And while Prime 1 is busy digging, Athena's robotic companions are also getting ready to make their mark. Remember Grace, that little hopper spacecraft?
Yes, Grace is a small spacecraft that's designed to hop around the landing site using its thrusters. Think of it like a mini explorer that can potentially reach areas inaccessible to rovers.
Like those permanently shadowed craters again.
Exactly. Our rover might have a hard time navigating the terrain around those craters, but Grace can just hop right over them.
So Grace could be the key to getting a closer look inside those craters, where the most significant deposits of water ice are likely to be.
That's the idea. It could even collect samples from those areas, potentially providing even more detailed information about the composition of that ancient ice. It's like having a scout that can go where no rover has gone before.
It's incredible how each of these robots seems perfectly designed to fill a specific role in exploring this uncharted territory. And of course, we can't forget about MAPP, the rover that hitched a ride with Athena. What kind of exploration is it doing?
Well, MEPP is more of a traditional explorer. It's equipped with cameras and sensors to study the geology and topography of the area around the landing site. It's creating a detailed map of the region, helping us understand the processes that have shaped the lunar surface over time. And don't forget, it's carrying that tiny AstroAnt prototype, which is gathering data on how swarms of small robots could work together in this environment.
It's like having a whole team of robotic geologists working around the clock. It's amazing how much technology they've packed into this mission. And of course, there's that 4G LTE network we were talking about. It's still mind-blowing to me that there's a cellular network on the moon.
It really is remarkable. It's connecting all of these robots, allowing them to communicate with each other and relay data back to Earth. It's a test run, really, for the kind of communication infrastructure we'll need for a future lunar base.
So it's not just about science and exploration. It's about building the foundation for a sustainable human presence on the moon.
Precisely, and that brings us to an important point. Remember, Athena's mission isn't open-ended, it's running on a tight schedule.
Right. We talked about the 10-day mission window, with the lunar night approaching. The clock is ticking for Athena and its robotic crew to make the most of their time.
Exactly, every minute counts.
So what happens next? What should we be looking out for in these final days of the mission?
Well, I'm particularly interested in the data Prime 1 collects as it digs deeper. I want to see if those initial findings of water ice are confirmed, and if we can get a sense of how much might be there. It would also be fantastic if Grace manages to hop into one of those permanently shadowed craters. The images and data it could gather from those areas would be priceless.
And I'm eager to see what MAPP uncovers as it explores the surrounding landscape. Its high-resolution images are going to give us a whole new perspective on this fascinating region of the moon. But before we get carried away with all the possibilities, we should acknowledge the elephant in the room. 10 Earth days is not a lot of time to accomplish all of these objectives.
That's true. The mission is limited by the availability of sunlight, and once the lunar night falls, Athena and its companions will power down until the sun returns. It's a reminder of the challenges of working in this harsh environment.
It's a delicate dance, isn't it? Pushing the boundaries of exploration while respecting the limitations of the lunar environment. But even with these constraints, it's remarkable how much Athena has already accomplished. It's a testament to the ingenuity and determination of the team behind this mission.
Absolutely. And despite the time constraints, I have a feeling we're going to be amazed by what they're able to achieve in these final days. There's still so much to learn, so much to discover.
Welcome back to our deep dive into Intuitive Machines' Athena mission. It's kind of crazy to think that we're already at the final chapter of this lunar adventure. We followed Athena's journey from that nail-biting landing to its groundbreaking explorations at the lunar South Pole. We saw Prime 1 digging into lunar history, Grace hopping across those craters, and MAP capturing those incredible images.
Yeah.
And all connected by Nokia's 4G LTE network. I mean, it's been quite a ride.
It really has. And as the lunar night approaches, marking the end of Athena's 10-day mission, it's a good time to kind of step back and reflect on the significance of this mission.
Yeah, absolutely. We've talked about the technological advancements and the incredible data being collected.
Yeah.
But I'm curious at the broader implications. What does Athena's mission mean for the future of humanity in space?
Well, I think Athena is a powerful symbol of a new era in space exploration.
Okay.
It's demonstrating the potential of public-private partnerships with companies like Intuitive Machines working alongside NASA to achieve, these ambitious goals.
Right.
It's a more cost-effective and sustainable model, paving the way for more frequent and ambitious missions to the moon.
It's like we're entering a new space race.
Yeah.
But this time, it's a collaborative effort, a global push to unlock the secrets of the moon and establish a lasting human presence there.
Exactly. And the lunar South Pole, with its potential abundance of resources, particularly water ice, is crucial to that vision.
Yeah.
Athena's findings could be instrumental in shaping future missions, including the Artemis program, which aims to land astronauts back on the moon.
So we're not just talking about short visits to the moon anymore. Athena's mission is laying the groundwork for a future where humans could live and work on the moon for extended periods, perhaps even establishing permanent settlements.
That's the ultimate goal.
Yeah.
And the resources found at the lunar South Pole, especially water ice, make that vision more attainable.
Yeah.
Remember, we can use that ice not just for drinking water, but also to produce rocket propellant,
Oh, wow.
which would significantly reduce the cost and complexity of deep space missions. Imagine launching missions to Mars or beyond from a lunar base fueled by resources harvested right there on the moon.
It's incredible to think about, but it's not just about exploring the cosmos.
Yeah.
How do you think Athena's mission will impact life here on Earth?
Well, space exploration has always been a driver of innovation. The technologies developed for these missions often find their way into everyday life, from GPS and satellite communication to medical imaging and advanced materials.
So the benefits of missions like Athena extend far beyond just scientific discoveries. They have the potential to improve life for everyone on Earth.
Absolutely. And perhaps just as important is the inspiration it provides.
Oh, yeah.
Seeing these incredible missions succeed, watching humans push the boundaries of what's possible, can ignite a spark of curiosity and wonder in people of all ages.
It's a reminder that we are capable of achieving extraordinary things when we set our minds to it.
And that's perhaps the most enduring legacy of missions like Athena. It's not just about the data collected or the technologies developed, it's about the human spirit of exploration, the drive to push beyond our limits and reach for the unknown.
That's a beautiful way to put it as we conclude this deep dive into Athena's mission. I want to leave our listeners with a question to ponder. What role do you envision for yourself in this new era of lunar exploration? Will you be following the progress of future missions? Will you be inspired to pursue a career in science or engineering? Or maybe you'll simply look up at the moon with a renewed sense of wonder and appreciation for the incredible achievements happening just beyond our world. Whatever your paths are trying us, keep exploring, keep questioning, and never stop reaching for the stars.
Keep looking up.
That's a wrap on this episode of The Deep Dive. Thanks for joining us, and until next time, keep looking up.